Hello, and welcome to Structural Analysis MCAD. This video demonstrates the use of the reinforced concrete column design sheet. Some of the features include it analyzes any rectangular concrete column for vertical load plus a unidirectional moment. It automatically plots a moment load interaction diagram and shows the applied load combinations. It plots eccentricity for selected cases. Bidirectional bending and shear will be added soon and provided at no cost. A circular column option will be provided soon. A material takeoff is provided for a specified column height, but no bar cutoffs are uh, done at this time. For use of this sheet, the load inputs start on page 1. In this case, there's dead load, live load, snow load, live load, wind load, and seismic load. Applied moments for the same are dead load, live load, snow load, live load roof, wind load, and earthquake loads. Note again that this is for a rectangular column of dimensions B and H with a moment in one direction only. Uh, if you want to do weak axis bending, you simply flip the uh, depth in the H direction, or the B and the H. Load combinations are provided on page 2. These are the factored load conditions from ASCE 7. Inputs began on page 3. They include, this is anything that's yellow is input previously or calculated, and the blue is input. The width and depth are calculated or input below. Here we have crushing strain as an input, modulus of the steel is input, the modulus of the concrete is calculated as a function of the concrete strength. Phi factors are input on this page for bending, for tied columns, or and so on. Spiral columns and tied columns. The bar sizes are repeated here, but they're input below. The stirrup size is input here, and the covered depth is input here. All calculations are done in these collapsed sections. And the column section to be analyzed is shown in the following plot. The circles represent the number of bars, and the black line is the outline of the column. As soon as we can get this to stop. The depth and width are input in the blue along with the bar size, in this case number 8s. The number of bars per side, 6 in this case, concrete strength, and the yield strength of the steel. The eccentricities for selected cases are plotted, and percent of H are plotted. And the eccentricities are the dashed lines. The column curve is that's the allowable load is in blue, and the dashed green line gives us the maximum load vertically that can be applied. So for a particular column design, all of the magenta points must be inside the blue line and below the dashed line. In this case, they're not, so we can iterate by changing the height from 16 inches to, let's try 20 inches. And it'll recalculate. And notice we've extended the interaction envelope, but still we have 4 points that are outside. So let's try, we can try 24. And recalculating, and we're getting close. Perhaps we want to go, maybe we have a size limitation, so let's try a 16 inches of width. And we're getting closer, but still not enough, so maybe we want to try going up in the bar size. Go up to a number 9 bar instead of a number 8 bar. And we just made it. So another option might be to increase the concrete size, or concrete strength. See what happens when we change it to 4,000. And you can see now we're way inside, so maybe we want to go back to number 8 bars. And we're still there. Let's try number 10 bars and reduce the number to 5 and see what happens. So that works. So now we might want to go back on the depth of the column. We're a little bit out, so you can see we're getting close. So maybe it's 21 inches might work. You can see all of the load points now are inside, and so now we would use 5 number 10 bars on each face, 1, 2, 3, 4, 5, and it will be a column 21 inches deep, 16 inches wide with 4,000 psi. Here's some addition. This is the factored loads shown again, and for the balanced moment right here, it's the eccentricity is 18.64. The applied load is 484.5 kips, and the applied moment is 752.7 kip feet. And finally, we can show the column length. In this case, we selected 12 feet, so it has almost about 1 cubic yard. The minimum reinforcing is okay. The maximum reinforcing is okay. The weight of the steel, 517 pounds. The weight of the concrete is 3.9 kips. Thank you for watching this video on column design, and please contact us at info@structuralanalysismcad.com for specific instructions.